Hello viewers, thanks for subscribing to our channel and watching the videos. In this video, we will discuss on quicksort algorithm and how to sort an array using quicksort algorithm. Quicksort, it is one of the sorting technique which is based on divide and conquer strategy. It is completely different when compared to other sorting techniques. The quicksort algorithm was developed by C.A.R Hoare in the year 1962. What is the basic principle of quicksort? The basic principle of quicksort is that you just pick any one element in an array and arrange the remaining array elements around it. That means whenever you pick an element, the element will be sorted in the correct position, dividing the array into two sub-arrays. Because it is partitioning the array, this sorting is also called as partition-exchange sort. Let us go into detail on how quicksort works. The first step of the quicksort is pick an element from an array. This chosen element is named as pivot element. What element should I pick from an array? You can pick either the first element of an array or the last element of an array. That is to the user choice. Once the pivot element is chosen, all the array elements which are less than this pivot are moved towards the left of the pivot element, and all the array elements which are greater than or equal to the pivot are moved towards the right side of a pivot element. Therefore, the pivot element is acting as a partitioning which divides the original array into two sub-arrays. The left sub-array with the values less than pivot and the right sub-array with the values greater than pivot. The pivot is ultimately in the correct position. On the two sub-arrays, the process will be followed again until all the elements in the array are sorted. This is how quicksort works. Let us now see step-by-step procedure taking an example. Here we are considering an array A which is having the 7 elements. The array index is starting from 1 and ending at 7. The very first element, that is at the index 1, we are picking it as pivot element. Here we are indicating the pivot element with an indicator P. So in this example, 45, the very first element of array, is taken as a pivot element. Here make a note that while choosing a pivot element, you can either choose the very first element of an array or you can even choose the last element of an array. In this example, we have chosen the first element. Second step, here we are doing iteration. For iteration purpose, I am using a variable called I. What iteration we are doing here? You start the iterator value at the second position and compare with pivot element. If the array element at the index I is less than the pivot element, you need to move the I value to the next array element. If the I index of array is greater than or equal to pivot, then you need to stop the iteration. Let us see with an example. So I started I at the index 2, that is the second value of the array element. Now I am comparing the value of pivot and the A of I, that is array element at ith index. So 45 and 23. 23 is less than 45. Hence, I should move to the next array element. The next array element is 65. So when you compare the 65 with the pivot value 45, 65 is greater than 45. So we are stopping the iteration. I iteration stopped and I is marking at the index value 3 in the array. Now we will move to the third step. Similar to the step 2, this is also an iterator step, but in this step, we will start iteration from the last element of an array. For this purpose, I am taking a new iterator variable called j. The same process. You need to compare the pivot element with the value where j is pointing, that is a of j. If the array element, that is a of j, is greater than pivot, you need to move the j iterator to the before element in the array. If the array element is less than or equal to pivot, you need to stop the iteration. So now you can see in the example, I am taking the j iterator initially pointing to the last element of an array, that is 54. Now I am comparing the pivot with j index of array, that is 54 and 45. 54 is greater than 45. So j should be moved to the previous element of an array. Now j is pointing to 78. Compare the values of pivot and a of j, that is 45 and 78. 78 is greater than 45. So again j should move to the previous element in an array. So it is pointing to 18. Now compare 45 and 18. 18 is less than 45. So we are stopping the iterator j. Second step, I iterator has stopped at particular position, and in the third step, j iterator has stopped at particular position in the array. Now in the fourth step, we need to consider the index value where I is pointing and j is pointing. Once again note that we are comparing index values but not the array elements. You can see here in the example, I is stopped at the index value 3 of an array and j stopped at the index value 5. If I is less than j, then you need to swap the elements in I and j, that is a of I and a of j, and continue with the steps 2 and 3 again. When we need to stop this, if I value is greater than equal to j, then you need to stop the process and you need to swap the pivot element with a of j. So let us see in our example. In our example, I value is pointing to 65, that is at the index 3. J value is 18 at the index 5. I need to compare indexes I and j, that is I 3, j equal to 5. Now 3 is less than 5, that is I is less than j. Whenever I is less than j, I need to swap a of I and a of j. So I have done swapping of 65 and 18. Note that I and j are still at the same index positions, they have not moved. As per the step 4a, after swapping, I should repeat the process of step 2 and step 3. So I am going back again to repeat the process step 2. That is iterating I. So now where is the I value? It is 18. So I am comparing 45 and 18. 18 is less than 45. So move I to the next position. Now I is pointing to 32. 32 is less than 45. So move I value to the next position. I is now pointing to 65. 65 is greater than 45. So you are stopping I iterator. Then we'll continue with j iterator. In the fourth step, the j iterator stopped at 65. So compare 65 and 45. 65 is greater than 45. So now you need to move j iterator towards the previous element. J is pointing to 32. 32 is less than 45. Therefore, we need to stop the j iterator. Now we will check the conditions in the fourth step. I iterator stopped at value 65 at the index position 5. J iterator stopped at index value 4 with a value of 32. Now what should I compare? I should compare the index values of I and j. Index value of I is 5. Index value of j is 4. Is 5 less than 4? No. 5 is greater than 4. If 5 is greater than 4, we need to swap the element where j is pointing, that is a of j, with the pivot element. So in our case, j is pointing to 32 element, pivot element is 45. So we are swapping 45 with 32. Now after swapping, you can see that the pivot element have taken the correct position in the array, and it partitioned that array into two sublists. If you can observe, all the elements less than 45 are towards the left side, and all the elements greater than 45 are towards the right side. So 45, that pivot, is nothing but the partitioning element, and we partitioned at which index? Array index 4. So we will be repeating the same steps 1 to 5 on left sub array as well as on the right sub array. Then finally, all the elements will be sorted. This is how the quicksort algorithm works. Let us write the algorithm for it. Writing an algorithm is the easiest task when we understood the process how it works. As we are aware, the major steps of quicksort is what? I need to find out the partitioning index, and then it will divide into two subarrays, left and right. I need to perform the quicksort on both separately. This is overview. So the same thing we are putting in the algorithm. We are naming that algorithm as quicksort. The input we are taking array A. This array index values is starting from 1 and ending with n. I am taking two variables as an input for this, low and high. Low is starting index of array, that is 1. High is ending index of array, that is n. We can sort if and only if there are at least two elements, right? That means low should be less than high. So I am checking the primary condition if low is less than high. Then what should I do? First, I need to find out the index value where I need to partition the array. So I am taking p index as a variable which is used to store the index of an array where the partitioning has to be done. So partitioning we will write in separate algorithm. Partition algorithm, I am passing the array A along with starting and index of array. This algorithm will return the position of partitioning. That is in our case the jth position in the example, that is 4. So that whatever the position it has returned, it will store in p index. Now when we have got the position that is 4 in the previous example, what we have done? We divided the left subarray from 1 to 3 and right subarray from 5 to 7 in the example, and we repeated the process. So then we are again doing the same here. Quicksort A low to index minus 1 left subarray. Quicksort A index plus 1 to high right subarray. Continue the process. So this is the quicksort algorithm. How to get that partition index value? We have seen, right? The same steps we will try to put it in an algorithm. Partition algorithm, we are name it as partition, and A is the array. Low and high indicates the starting and ending index of an array. Here we are choosing three variables. One is pivot, I and j. We have done the same in example as well, right? So pivot is a variable which is used to select the pivot element. I and j are used for the iteration variables. In our example, we have selected the first value as a pivot value, correct? That means arrays with the starting index, A of low. Low indicates here the starting index. So A of low value is stored in the pivot. This is step 1. Now I need to start I and j iterators. Before that, from where I need to start I? I should be started from the second position. That is nothing but low plus 1. So I is equal to low plus 1. From where j iterator should start? J iterator should start from the last element of an array. That is nothing but high. So j is initially pointing to the high of an array. So I have initialized I is equal to low plus 1, j is equal to high. Now come to the second step, I iterator. What is we have discussed? We need to compare a of I with pivot. If a of I is less than pivot, I should move to the next element. And this process should continue until a of I is less than pivot only. In case if it is greater than equal to, we need to stop. So the same thing I am repeating. Because it is an iteration, I am making use of a loop. While loop, it should continue until a of I is less than pivot. Keeping the condition here, while a of I is less than pivot. If a of I is less than pivot, then only what should I do? I need to move I to the next position in an array. So I plus plus. So while a of I less than pivot, I plus plus. This is our second step. Somewhere I will be moving and stopping. What is the third step? We need to start j iterator. Wherever j is there, you need to compare a of j with pivot. If a of j is greater than pivot, then you will be moving j to the previous position. Otherwise, you will stop it. Again, it is an iteration, so I am using a loop. What condition should satisfy? A of j should be greater than pivot. Then only j will go to the previous, that is j minus minus. So when I write while a of j is greater than pivot, j minus minus. This is the step 3. We discussed in the step 4a, you need to compare I and j. I and j pointing to what? Index values. Suppose I index value is less than j index value. What we need to do? We need to swap both a of I and j. So I am writing with an if condition. If I less than j, swap a of I comma a of j. And after doing swapping, we said we need to repeat step 2, 3 again. That means for repetition purpose, again I want a loop. So I need to keep this 2, 3, 4a in a loop. But how many times it should repeat? Until I is less than j. Whenever I is greater than equal to j, we need to stop, right? So the 4b step, what I am doing is I am keeping the step 2, 3, 4a within a while loop while I less than j. So this completes step 2, 3, 4. At some point of time, I index will be greater than or equal to j. Then we will be coming out of the loop. At that case, what should I do? I should swap the pivot element with a of j. So I am writing the step 5, swap pivot comma a of j. Now the pivot element is positioned correctly in an array. To divide this array, I want to know the index value, right? That is j value. So I am returning j. Partition algorithm always returns the index value where we need to partition. So this value is given to the previous quicksort algorithm. So here we used one extra algorithm called swap. Generally, swap is an algorithm used in all sorting techniques. It is well known to all. But just to recall, we are giving again. Swap is an algorithm with the name having two input variables to be swapped, a and b. For easy purpose, I am taking temp as a new variable here. We are initially storing the value of a into temp. Then we'll copy the value of b to a and temp value to b. That is nothing but temp equal to a equal to b equal to temp. This is very simple logic of swap algorithm. We can also do swapping without using temporary variable. That is up to the programmer. In this video, we have seen how to sort an array using quicksort algorithm, and we have also written the algorithm for it. Here one point you need to make a note, quicksort algorithm majorly revolves around selection of pivot element and partitioning the two sub-arrays. So this pivot element, whatever you are selecting, must be either the first element of an array or the last element of an array. This is all about quicksort algorithm. Hope you have understood. If you have any doubts on it, you can comment under the video. We will respond back to your doubts. In the next upcoming videos, we will see how to calculate the time complexity of the quicksort algorithm. Please subscribe to our channels. Thank you for watching.